Yesterday we have seen some sums on root locus. Today we are going to see more sums on root locus. Then we are going to
prove
see
that
design of control system
breakaway
using
and
root locus.
break-in points will exist only when modulus of A is greater than modulus of B. Prove that the complex points on the root locus form a circle with center minus A comma 0 and radius square root of A square minus AB.
One pole is here. What are the poles? Poles are 0 comma minus B. 0 comma minus B. Zeros are at minus A. One pole at the origin. Sigma j omega S plane. Modulus of A is less than, let us assume. Modulus of A is less than means modulus A will be here. A will be here. A will be here. And B will be here. Because modulus of, we are assuming that modulus of A is less than modulus of B. Any point between minus A and 0 is part of root locus. Any point between 0 and minus A is part of root locus. Between minus A and minus B, it is not part of root locus. Am I correct or not? Because 2 is right, even number of poles and zeros. Therefore, it is not part of root locus. But after B, if you select any point up to infinity, up to minus infinity, it is part of root locus. This is root locus. This is also root locus. That's all. One will end at 0, another one will end at infinity. That's all. Root locus is over. Root locus is over. This is 2 marks question. If they ask modulus of A is less than modulus of B, this is the root locus. Sum is over. So draw a rough root locus branch for a given sum means you have to draw like this. 2 marks question. But if modulus of A is greater than modulus of B, what will happen? One pole will be here. Modulus, this is another pole. Minus A. This is minus B. Sorry. This is minus B. This is minus A. Modulus of A is greater than modulus of B. So now, this is part of root locus. This is part of root locus. Because between minus B and 0, all points between minus B and 0, to its right, we have odd number of poles and zeros. Both are starting points. Here, this is end point. This is starting point. That's why no problem. No breakaway point. But here, both are starting points. Definitely, there will be a breakaway point. There will be a breakaway point. And between minus A and minus B is not as usual. Between minus A and minus B, no root locus. But after minus A, all points after minus A is part of root locus. Up to infinity, it is part of root locus. But this is, both are endpoints. Infinity also endpoint. This minus A also endpoint. Therefore, some branch must come and join here. One branch go to this side, another branch go to that side. That is called break-in point. Break-in point. Break-in point. This is called, it is coming out. It is coming out. Therefore, this is called breakaway point. Breakaway point. So the root locus will be like this. somehow it will come and join here, and this also come and join here.
But second part of the question is prove that the complex points, these are all complex points. Complex points. If it is not on the real axis, then it is called complex points. The complex points form a circle. We have to prove that it forms a circle. It forms a circle. We have to prove that it forms a circle. That is second part. First part is if modulus of A is greater than modulus of B, then only it will have breakaway point. First part is prove that break-in points will exist only when modulus of A is greater than modulus of B. Evans condition. For a point to be on the root locus is modulus of G of S naught must be equal to 1. Angle of G of S naught must be equal to plus or minus 2q plus 1 multiplied by 180 degree. So the first condition is this is k times. This is k times. This is also k times. Angle of k is 0. That's why we can leave it. For any one value, the first condition will be satisfied. Therefore, to draw root locus, we need not bother about the first condition. We need not bother about the first condition. So we have to consider the second condition alone to draw the root locus. Therefore, we'll apply the second condition. 2q plus 1. When q equal to only one angle, that's why q equal to 0 means you will get plus or minus 180 degree. Or I can say that plus or minus pi. Or I can say that plus or minus pi. Minus pi. Plus or minus pi. I'm taking minus pi. So angle of G of S naught, angle of G of S naught equal to minus pi. What is S naught? S naught is a complex point. S naught is a complex point means both real part as well as imaginary part will be there. If we select any point S naught on this, that is equal to sigma plus j omega. Am I correct or not? Sigma plus j omega. Therefore, S naught is angle of G of sigma plus j omega equal to minus pi. What is G of j omega? G equal to what? What is G? G equal to K multiplied by S plus A. G of S equal to, given that K multiplied by S plus A upon S multiplied by S plus B, that is given. But S equal to what? Sigma plus j omega. Therefore, this implies angle of K multiplied by sigma plus j omega plus A whole divided by sigma plus j omega plus B. This is equal to, this implies how to find angle. Angle for this, angle for numerator is positive. Already we have seen. Angle for denominator is negative. What is the angle? Tan inverse of imaginary part divided by real part. Therefore, for numerator, angle of k is 0. Angle of k is equal to 0. That's why we can ignore. So, tan inverse of imaginary part divided by real part minus, why I put plus? Because numerator, minus tan inverse of omega divided by sigma minus tan inverse of omega divided by sigma plus b equal to minus pi, because we are assuming that it is 180. So bring this positive value to the right hand side. Bring this positive value to the right hand side. What you will get is minus tan inverse of omega by sigma minus tan inverse of omega divided by sigma plus b equal to minus pi minus tan inverse of omega divided by sigma plus A. So if we take all are negative, that's why we can make it as positive. Take tan on both sides, tan of, because tan inverse is theta, tan A plus B. Here also you can take tan on both sides, tan inverse of omega by sigma is angle A. Let us assume that this is A, this is B. Therefore, tan A plus B, tan A plus B equal to tan A plus B equal to tan A plus tan B divided by 1 minus tan A tan B. That is equal to tan of tan inverse of omega by sigma is omega by sigma. Tan A plus tan B, that is omega divided by sigma plus B whole divided by 1 minus tan A tan B, omega divided by sigma multiplied by omega divided by sigma plus B. That is equal to that is equal to that is equal to that is equal to that right side tan. If you take tan pi, tan A is tan pi plus omega divided by sigma plus A whole divided by 1 minus tan pi multiplied by omega divided by sigma plus A. Tan pi 180 degree, 0. This is also equal to 0. Therefore, we can write this as omega divided by sigma plus omega divided by sigma plus B, left hand side, equal to, you bring this to the right hand side. You bring this to the right hand side, you will get 1 minus omega square divided by sigma multiplied by sigma plus B multiplied by omega divided by sigma plus A. I can cancel this omega. If you take omega outside, this omega and this omega will getting cancelled. LCM, sigma plus B. Here you will get sigma plus B plus sigma, left hand side. Right hand side, what you will get? Right hand side, what you will get? Right hand side, if you take the LCM, you will get sigma multiplied by sigma plus B, sigma plus A. Here you will get, instead of 1, you will get sigma square plus sigma B minus omega square. You will get. So this getting cancelled. This is also getting cancelled. 2 sigma plus B multiplied by sigma plus A equal to sigma square plus sigma B minus omega square. Or you will get 2 sigma square plus sigma B plus 2 sigma A plus AB equal to sigma square plus sigma B minus omega square. Minus omega square. Minus omega square. That is equal to, if you bring this sigma square here, you will get sigma square. Sigma B getting cancelled. Sigma B getting cancelled. Plus 2 sigma A plus omega square
equal to, this is written, AB is there, minus AB, equal to minus AB. Deliberately add on both sides A square. Deliberately add on both sides A square. A square plus A square. So this A square plus sigma square, 2 sigma A can be written as sigma plus A whole square plus omega plus 0 whole square equal to A square minus AB. So sigma is real axis, omega is imaginary axis, x axis, y axis, like that. X plus A whole square plus y plus B whole square equal to R square is equation of circle. Therefore, the center is at minus A comma 0. The radius equal to square root of A square minus AB. Radius is A square minus AB. Therefore, the complex points on the root locus is a circle. It forms a circle. Second part is proved. The open loop transfer function of a feedback system is G of S equal to K multiplied by S plus A upon S multiplied by S plus B. That is that is the open loop transfer function. We have to prove that the breakaway point and break-in points will exist only when modulus of A is greater than modulus of B. To find breakaway and break-in points, we have to find K. Because dk by ds equal to 0 will give the breakaway and break-in points. Therefore, K in this case, K equal to minus S multiplied by S plus B upon S plus A. Therefore, dk by ds equal to dk by ds equal to S plus A whole square, S plus A multiplied by 2S plus B minus S square plus BS. The derivative of S plus A is 1. That's all. That is equal to 0. It is equal to 0. Therefore 2S square plus BS plus 2AS plus AB minus S square minus BS equal to 0. B is getting cancelled. Therefore, that is equal to S square plus 2AS plus BA. The roots are S equal to minus 2A plus or minus square root of 4A square minus 4BA upon 2 getting cancelled. Therefore, what we are getting is minus A plus or minus square root of A square minus BA. This will be real root only when A square is greater than BA or A is greater than B. Therefore, modulus of A must be greater than modulus of B. Then only it will have real roots. In other words, when modulus of A is greater than modulus of B, then the system, the root locus will have breakaway and break-in points. Breakaway and break-in points. So based on this, we can see some sums.